Have you ever had this really frustrating problem where you're exhausted trying to fix it?
Oh, absolutely.
Right. Like you're doing all this painstaking manual labor trying to maintain control over a situation, but then by pure accident, you stumble on a solution that is just, well, it's the exact opposite of what you were trying to do.
Yeah, where the actual fix is something you've been actively avoiding.
Exactly. Like taking a notoriously aggressive, bad-tempered predator that you usually try to keep completely away from your delicate ecosystem and just dropping it right into the center of the chaos.
It's basically the ultimate lesson in giving up the illusion of control, honestly,
Yeah.
because we spend so much energy, you know, trying to micromanage complex systems, whether that's an actual biological environment or like a corporate team or even just our own daily schedule.
Oh, the daily schedule micromanagement is real.
Right. We always treat the symptoms through sheer brute force. But the moment you stop fighting the system and actually look at the behaviors that are already in it,
Mm-hmm.
you often find the problem can literally just eat itself.
Which is exactly what we're going to unpack today on this deep dive. We're exploring this fascinating shift from tedious manual labor to just letting nature do the heavy lifting.
It's a great topic.
It really is. We are looking at a highly specific, real-world field note published on July 15th, 2026. It's called Notes on Fishkeeping, Part 289.
Written by an aquarist named Ang.
Yeah, Ang. And at first glance, Ang is just trying to do some routine tank maintenance.
Just normal, everyday stuff.
Right, but it turns into this incredible microcosm of biological problem solving. So, okay, let's unpack this. The whole inciting incident starts with a project.
A very ambitious project, really.
Yeah, Ang is setting up this pristine, brand new aquarium, and it's for a very specific pair of fish called kribensis-cichlids.
Scientifically known as pelvicachromis-pulcher for the biology nerds out there.
Love it. But yeah, when you're setting up a tank for a specific pair like that, you are basically trying to engineer perfection. It's like prepping a pristine nursery for a new baby. Oh, that's a perfect way to describe it. Everything has to be exactly right. The water parameters, the temperature, the layout.
Exactly. But as Ang is getting this nursery ready, a massive issue pops up. The rest of the house, or in this case, the existing aquarium tanks, have been totally overrun by these tiny, slow-moving squatters.
Malaysian Pond Snails.
Yes, or radix-sp.
Right. And, a few snails in an aquarium. Totally normal. They can even be beneficial, breaking down waste and stuff.
Sure, but Ang's notes specifically describe this as an, quote, exploding snail bloom.
Which is a critical phrasing.
Because a bloom isn't just a couple of extra pests, right?
No, not at all. In biology, a bloom means the carrying capacity of that environment has just been totally blown open.
Like they've got unlimited resources, so...
Well, exactly. The organism is reproducing exponentially to fill the void. The system is completely out of balance in favor of the snail.
So faced with this exploding bloom, Ang's initial reaction is, well, it's incredibly relatable, but totally flawed.
The manual scooping. Yes. Ang's usual method is manual removal, literally taking a net and physically scooping these tiny snails out of the tank by hand.
It sounds exhausting just thinking about it.
Right. And not just scooping them out, but moving them to other tanks. When I read that, I just thought, wait, isn't that just shuffling the problem around?
It is entirely shuffling the problem around. What's fascinating here is that manual removal is just such a classic human reaction to a systemic issue.
We want to feel like we're doing something.
Exactly. We treat the symptom instead of the root cause. You are fighting exponential growth with linear effort.
Like bailing water out of a sinking boat with a colander.
That's exactly it, because biology moves so much faster than your hands can. You scoop out 50 snails, but there are hundreds of microscopic eggs already hatching in the gravel.
You aren't actually managing the ecosystem at all. You're just doing this endless chore.
A Sisyphean chore, really. And to your point about moving them to other tanks, that is the true danger of manual intervention in a crisis like this.
It's like having an overflowing email inbox, right?
Oh, yeah.
And instead of, unsubscribing from the spam or setting up a filter, you just drag all the spam emails to a different folder and pretend your inbox is clean.
But the data is still there. The snails are still there. You just seeded a systemic failure into a new environment.
Which is just wild when you think about it. But I think Ang finally hits that breaking point. The sheer scale of this bloom makes it obvious that scooping is just mathematically doomed.
The realization that brute force isn't going to work.
Yeah, so Ang abandons the net, And here's where it gets really interesting, because Aang looks around at the resources available and makes a very targeted, kind of aggressive choice.
Very aggressive.
Instead of just spreading the snails around randomly, Aang takes them and feeds them to a specific tank that houses the Golden Mbuna.
Melanochromis-auratus.
Right. And the source specifically points out that the Golden Mbuna is notorious for being incredibly aggressive and territorial.
It is a fundamentally mean fish in the aquarium hobby.
Yeah. It's basically the grumpy nightclub bouncer of the aquarium, which seems totally counterintuitive, right? You've got this delicate ecosystem problem, and your fix is to introduce the most aggressive variable you have.
Well, it changes the dynamic entirely.
Right.
Because unlike the other cichlid species in Aang's care, which just ignored the snails, the Golden Mbuna reacted differently.
It immediately started nibbling on them. The note says it seemed to relish them.
Right. And that comes down to how this specific species interacts with its space. Territorial aggression isn't just an attitude problem. It's a biological mechanism.
Okay, wait, explain that. What makes this aggression productive here?
So a highly territorial fish like the Golden Mbuna actively investigates and dominates everything that enters its zone. If another cichlid sees a hard-shelled snail, it might just think, well, that's not a fish flake, and ignore it.
Right, they just swim past it.
But the Mbuna's instinct is to violently test and bite intruders.
Oh, wow, so it bites the snail just to defend its territory?
Exactly. It cracks the shell out of aggression, but then suddenly realizes, oh, wait, this intruder is actually packed with protein.
That is amazing. So the territorial drive accidentally unlocks this new food source.
Yes. A new behavioral loop is instantly formed. Aang took this massive liability, the Mbuna's hyperaggression, which usually just causes stress in a tank, and channeled it into a productive balancing force.
It's brilliant because, going back to my bouncer analogy, a bouncer is still manual labor, right? You're still paying someone to throw the riffraff out.
Right.
But this isn't a bouncer. This is more like a biological thermostat.
I really like that framing. A thermostat.
Yeah, because a thermostat works on a feedback loop. If the temperature gets too high, the AC automatically kicks on to bring it down.
And in this ecosystem, the snail population is the temperature.
Exactly. When the snail population spikes, it triggers the Mbuna's feeding response. The fish eats the snails, the population drops back to baseline, and the system regulates itself. No nets required.
It reveals this profound philosophy about ecosystem dynamics. A pest is really only a pest until you find the specific creature that considers it a delicacy.
Oh, that's such a good point.
Because the snail itself didn't change, right?
Yeah.
It's the exact same organism in the kribensis tank as it is in the Mbuna tank.
The only thing that changed was the context. To the pristine baby nursery tank, the snail is a destructive squatter. But to the aggressive Golden Mbuna, that exact same snail is a gourmet meal.
Aang essentially stopped trying to fight the system from the outside. Instead, they just connected two conflicting elements from within the system and let them neutralize each other.
And you can see how much this success shifts Aang's entire perspective in the field note. It goes from a lucky accident to a deliberate strategy.
The wheels definitely start turning.
Oh, yeah. Aang immediately starts asking the broader question. What other freshwater fish naturally eat snails?
Which is a huge evolutionary step in problem solving. We're moving from a reactive fix to proactive ecosystem engineering.
So, what does this all mean for the future of Aang's tanks? The source notes that Aang identifies 3 other, quote, usual suspects for natural snail control.
The loaches, the pufferfish, and the gouramis.
Right, and these aren't just random fish. They are basically specialized biological tools, right?
Highly specialized. If we connect this to the bigger picture, you look at something like a pufferfish. They have these specialized beak-like dental structures.
Wait, pufferfish have beaks?
Kind of. They have teeth fused into a beak shape, specifically evolved for crushing hard shells. For them, eating a snail isn't just a snack, it's actually biologically necessary to grind their teeth down so they don't overgrow.
That is wild. So it's not even a choice for them, it's maintenance.
Exactly. And then you have loaches, which operate completely differently. They are bottom dwellers. They constantly sift through the substrate, the gravel at the bottom.
Which is where the snails hide and lay their eggs, right?
Right, so the loach is eradicating the problem at the root, before the snails could even mature into a visible bloom.
And then the gouramis.
Gouramis are more meticulous midwater hunters. They pick at the smaller, newly hatched snails along the surfaces.
So you've got crushing force with the pufferfish, substrate eradication with the loach, and surface hunting with the gourami.
It's a multi-tiered defense system.
Which brings me to, honestly, the funniest, most relatable part of this whole field note.
Oh, the rationalization.
Yes, Because Aang admits to having thought about getting loaches or pufferfish in the past just because they're cool fish.
But now there's this exploding snail bloom.
Exactly. And Aang writes, quote, "Judging from the exploding snail bloom, this is probably a good opportunity to explore these two options further."
It is the ultimate human rationalization.
I laughed out loud when I read that because we all do it. You have a crisis and you instantly reframe it as the perfect excuse to buy that expensive new gadget you've been eyeing.
Oh, absolutely. Well, my car made a weird noise. Guess I have to buy a whole new sports car.
Right. Oh no, a snail bloom. I have literally no choice but to go buy those exotic pufferfish. It's so funny. But, under the humor, it shows a massive intellectual leap.
It really does. If you map out the trajectory here, stage 1 was just pure frustration, manual labor with a net.
The Dark Ages.
Right. Stage 2 was the accidental success with the Mbuna. But stage 3, looking at the loaches and pufferfish, that is deliberate systemic integration. Aang is thinking like an architect now.
The mindset went from, how do I kill these pests, to how do I design a habitat that actually requires these pests to function?
That is the essence of biological control. If Aang adds a pufferfish, the snails aren't an invasive nuisance anymore. They're a critical part of the food web.
The system literally runs on the problem.
Exactly. The exploding bloom goes from being a failure of the system to being the exact fuel needed to run this new biological engine.
So, by expanding the arsenal to include these specific predators, Aang ensures that a future snail bloom won't even be a crisis.
The system will just naturally absorb the population spike.
Because the controls are already built in.
It creates a self-regulating baseline. The system can take a hit without requiring Aang to jump in with a net and intervene.
It's just such a brilliant blueprint for problem solving. I mean, just to recap this whole journey, we started with Aang trying to set up a pristine kribensis nursery, right?
Right, and discovering an overwhelming, mathematically unbeatable infestation of Malaysian pond snails.
And after realizing that scooping them out by hand is completely futile, Aang accidentally finds this natural mechanism.
Leveraging the hyperaggression of the Golden Mbuna to physically crush the problem.
Taking a behavioral liability and turning it into a biological thermostat, and from there, expanding the strategy to intentionally engineer a permanently balanced food web using specialized predators like loaches and pufferfish.
And the lesson here extends so far beyond the glass walls of a fish tank.
Oh, 100%.
Because every single day, whether you're managing a team at work, or organizing your house, or dealing with an overflowing inbox, you are going to face your own version of an exploding snail bloom.
Problems that just multiply faster than you can handle them.
And our instinct is always to grab the net.
To start manually sorting and micromanaging the chaos.
But Aang's note proves that brute force intervention in a systemic crisis almost always fails. When you face an overwhelming issue, you have to step back. Look at the architecture of your system.
Look at the resources, the tools, even the difficult personalities you have to work with.
Yes, you have to find your own Golden Mbuna, that natural existing force that inherently wants to consume the very problem that's dragging you down.
You channel the energy of the system to balance the system. It's so elegant.
It really is. And it raises an important question for all of us, I think.
What's that?
Well, if a closed environment like an aquarium can be perfectly balanced simply by introducing the right natural participant and just letting them do their thing, how often do we overcomplicate our own lives by trying to manually micromanage our problems instead of just letting nature take its course?
Wow. That is definitely something to think about next time you find yourself trying to scoop out a problem by hand.